Good afternoon, everyone. We'd like to introduce the Henry Spira Memorial Lecture. Since his death, Henry Spira, a passionate and effective social justice advocate, animal rights activist, and an uncommonly wise and grounded individual, has been recognized at Primer's IACUC conference through the Henry Spira Memorial Lecture. Primer hosts this lecture to honor his memory, commemorate his work with alternatives in the 3 R's, and recognize his ability to bring together the scientific and animal rights communities. Mr. Spira was a frequent participant at Primer's meetings. He emphasized the necessity of working across ideological lines and communicating with individuals and organizations that hold opposing viewpoints. Mr. Spira once stated, if there are going to be alternatives to the use of animals, it's the people in the research community who will be developing alternatives. If you're going to get the regulatory agencies to change their requirements, it's going to be animal researchers who are the ones who are going to do it. These are the folks that you need if you're going to be serious about change. In this spirit, and in Mr. Spira's memory, Primer is proud to present the 15th Annual Henry Spira Memorial Lecture, which will be given by Joseph Garner. Dr. Garner is an associate professor in the Department of Comparative Medicine, a courtesy associate professor in the Department of Psychiatry and Behavioral Sciences, and a member of the Child Health Research Institute at Stanford University. Dr. Garner runs Stanford's Technique, Refinement, and Innovation Lab. The overarching theme of Dr. Garner's research is understanding why most drugs and other basic science findings fail to translate into human outcomes, the role that animal models and methodology play in these failures, and developing new approaches to improve the translation and benefits of animal research while minimizing welfare impacts. Dr. Garner is an internationally recognized expert in the behavior and welfare of laboratory mice, and he also works extensively in human health, both as a researcher and an advocate. More information on Dr. Garner may be found in your conference guide. Please help me welcome Dr. Garner to our podium.
Wow, I got like coffee ad entrance music and everything. So it is an enormous pleasure to be here and really a phenomenal honor to have been invited, and thank you so much for not just the opportunity to speak, but to speak in memory of Henry Spira. So what I'm going to do today is actually unintentionally, maybe intentionally, I'm going to mesh a lot with some of the things that Bernie talked about this morning. Well, there's a saying out there, right? The first step in solving a problem is admitting that there is one. And I really feel that we're on a point of crisis. We've gotten ourselves into an existential crisis of our own making, and a crisis which, outside of pharma, we seem to be fundamentally unwilling to admit even exists, let alone try and solve. That's point number one. These are my take-home slides. I just, rather than take home, I'd like to have a better caption. The other thing that I really want to impress upon you is that in our field, we make a great deal about the difference between engineering standards and performance standards. And that applies to the IACUC too. The engineering standard of the IACUC may be that it's the gatekeeper to study approval, but the performance standard is fundamentally an ethical one. The point of the IACUC is to be the first and the last guarantor of the ethical, the societal, the scientific integrity and worth of the research that's being performed. And as in the current situation that I'm going to be talking about today, when all of the other checks and balances in the system have failed, when the granting agencies have failed, when the journals have failed, when peer review has failed, then the IACUC is the last line of defense, and the IACUC must act. So I don't think that this is a new idea, right? You know, a while ago, we were very nervous about IACUC suggesting analgesia. Oh, no, the drugs are going to interfere with the experiments. But now we're totally happy that an IACUC can enforce basic requirements in terms of analgesia, anesthesia, and aseptic technique. That's not who feels that's revolutionary? Okay, good. So what I'm going to persuade you is that in order to meet the current challenges that we face, we're going to require an evolution of our IACUCs. And now, for the same 3 R's reasons, for the same basic logic, they're going to start to need to require basic improvements and basic levels of quality in terms of study design, and I would actually argue proactive validation of basic PI knowledge and skills, which is shockingly lacking, as I will show you, and also informed decision-making by both PIs and facility operations. So that's my take-home message. Hopefully that is sufficiently dramatic. So what on earth am I talking about? Attrition is a phenomenon. Who here is in pharma or in a CRO? Okay, so if you're in pharma and a CRO, you have heard about attrition. Attrition is the simple fact that when I take a drug into human trials, the average success rate is 1 in 10, 1 in 11. So you don't need to go far to fact check me on this. This is data that I'm showing you out of the FDA, published in 2004 by Kohler and Landis. There are similar data sets out of regulatory bodies in Europe as well as out of the industry itself. And very consistently, in about the last 10 years or so, these data sets have shown that roughly 1 in 10 drugs will actually succeed in human trials. And for the longest time, people thought that this was something wrong with human trials because we're seeing these failures in human trials. And then around about 2010, there's a real sort of frame shift. And everybody began to point out, you know, wait a sec, when we look at why these drugs fail, 80% of these failures on average are due to a lack of efficacy. But every single one of these compounds worked in an animal model. That's why we did the human trial in the first place. So maybe the problem isn't with the human trials. Maybe the problem is that the basic animal work is producing an awful lot of false discoveries, and we're bringing those forwards into humans without ever having some sort of secondary check and balance. Why am I talking about this to a group of people who are, you know, concerned about IACUCs? Well, and again, Bernie can correct me if I'm wrong, but I think that the ethical justification that the IACUC is weighing up when they consider every study, when we think about the performance standard of the job of the IACUC, is does the benefit outweigh the cost? But what I don't think we're doing is I think we are not scaling that potential benefit by the chance that this study will translate. So, if the average chance that a study is going to translate is 11%, is any category D or E procedure justifiable? So again, if I want you to remember one thing, it's that question. Next time you read a protocol, know in the back of your mind there is only roughly a 1 in 10 chance that this study is ever going to result in something useful in humans. And can I really justify knowing that the category D and E procedures that are in that study? Well, as a matter of sort of simple cost-benefit utilitarian analysis, the answer to that is arguably no. And if you're not worried about this, you should be, because guess what? Peter knows about this, HSUS knows about this, ALF knows about this, and those people are coming for you. And they are coming for you with this data. And not because I told them about it, right? Because they went and read the papers, right? So the militant animal rights groups are very well aware of how poor our translation rate is. So luckily, I think, this issue is much more complex. So I'm going to try and argue to you that it's time for the IACUC to sort of step up. And step up to its performance standard. Step up to its role as the first and last guarantor of the ethical, societal, and scientific justifiability of the study. And to do that, obviously, an IACUC needs to be able to spot studies that are likely to fail to translate, and I think that is incredibly easy to do, and I'm going to walk you through a lot of the warning signs for the rest of this talk. And the IACUC needs to require PIs who are proposing a failure-prone study to increase the chance of translation. And again, there are some very simple things that I think you can require people to do which will improve the chance that their work will translate. So everybody wins, right? Sorry, but you have to have a fight, but everybody wins. So normally when I'm talking about this at this point, nobody believes me. So here's two wonderful studies, both published in 2010. The first one reviews, at that point in time, every single study ever published with the APP knock-in mouse. So this is the amyloid precursor protein knock-in mouse, the major model of Alzheimer's disease. There were 200+ studies at that point of reporting different compounds that appeared to improve memory in that animal. Of those compounds that were taken into human trials, none worked, and roughly 10% of them resulted in trials being terminated early because of adverse events. So that is a negative 10% success rate. And that should terrify you. And it's not just, knock-in mice. Let's take another example. Ischemic stroke. So again, same kind of systematic review. 500+ studies on ischemic stroke models, of which only 2 translated into humans, and one of those was with a compound which we already knew worked in humans. Everybody's just I can't really see faces. So I don't know if there's rotten tomatoes coming, but hopefully there's a little bit of going on as well. So there is this wonderful paper by Pauls, who was a senior researcher at Eli Lilly, and this is using internal data from Lilly and some other pharma companies, building the economic model of attrition. And if you're interested in this, this paper is so lovely. So the key point that comes out of this paper is that the average cost of bringing a drug to market is $2 billion, billion with a B. And 75% of that cost is the attrition that occurs in that company during the pipeline. All right? So when you break down where that cost occurs, almost all of it occurs in the human trials. Only 3% of the $2 billion cost of bringing a drug to market is due to attrition preclinically in animals. And so onto that graph, I would add my sort of little graph of the extent and invasiveness of animal use. We have absolutely no idea truly how many animals are used in different stages of drug discovery. But at least talking to my friends who breed animals and ship them, I think a decent estimate is probably roughly 50% of animal use is in preclinical tox. And that's a number that myself and a couple of other people are pretty willing to stand by. So Pauls and colleagues argue economically that maybe attrition can't ever be avoided, right? Maybe it's just going to be a fact of life that 90% of compounds are going to fail. But if we could detect them before we take them into humans, then the majority of the cost, the financial cost, is avoided. And that's the point they're making in this paper. But here's the thing. If we can detect those compounds before we go into preclinical tox, guess what? 90% of the welfare cost is also avoided. And so this is, I think, one of the best examples of good science, it's good business, it's good welfare, and it's also good public health. Because drugs are so expensive, and because you have such a short amount of time to make money off them, we can only make money for diseases which require long-term treatment, where people are well insured, where people seek help. And so, we're basically describing diseases that affect old, rich, white dudes. And in psychiatry, that's a very, very important point. There was this thing called Tuskegee, and that is why certain ethnic groups in America don't seek psychiatric help. This is why we have far more drugs for erectile dysfunction than we do for the third leading killer of women of childbearing age, which incidentally is childbirth. Right? We have 2 drugs for uterine hemorrhage. I've lost count of how many erectile dysfunction drugs we have now. I don't remember the last time that erectile dysfunction killed anybody. But you can go to the CDC, and the top killer of women of childbearing age, once you put aside murder, suicide, and accident, is childbirth, heart disease, and cancer. Which one of those is the top 3 depends on age. That, again, should terrify you and should offend you. It should offend you that we have 2 drugs for treating one of the top 3 killers of women of childbearing age. Anyway, sorry, I go on tangents. Back to tangents and being on time. So, again, at this point, I've said lots of offensive things and people are upset with me, so I need to make the point that there's a chorus in the wilderness, right? There's a whole bunch of people complaining about this stuff and talking about this stuff. And the amazing thing is none of us know each other. So we have like this just happened at a conference like 2 weeks ago. I randomly bumped into somebody and I'm like, oh, you're that guy. Oh, you're that crazy person. And the amazing thing is that even though none of us know each other, this emerging literature for the last 5 or 10 years has been saying exactly the same thing. All of us are saying more or less the same thing. So, all right. As IACUC members, how can you spot people that you might want to start worrying about? Well, the first step in admitting that you have a problem or solving a problem is admitting that you have one because, of course, there is denial. So if attrition is such a big issue, why is nobody doing anything about it? Well, Pharma certainly is. Pharma has largely disinvested in in-house animal research. And they've passed on that risk and the financial cost to academia and startups. And again, there's beautiful papers talking about this economic shift that's happened in the last 5 to 10 years. The NIH is, if you read Mental Health Strategic Plan, it's terrifying. It's a 38-page document, very detailed, in which animals are mentioned twice. And there are many, many areas of that strategic plan where you think, oh, there's an animal model for that. Oh, there's an awesome animal technique for that. But no, they're talking about convoluted ways in which you would do this in people because they basically are disinvesting in animal research. And that, you know, we will look back on Tom Insel's time at the NIH, and that's very clearly what happened of his tenure of mental health was a massive disinvestment in animal work. Elias Zerhouni, who was the previous head of NIH, in 2013, had this amazing conference there, and you can go to the NIH record, you can read the whole transcript, and at one point he's asked what would he have changed about his time there. The number one thing he would have changed about his time there was that, quote unquote, he wouldn't have been fooled by knockout mice. So the ex-head of the NIH is arguing fundamentally that we should be disinvesting in animal research. That, again, should frighten you. On the other hand, we have our lovely PIs, and I say this as a PI myself, right? PIs are the last to admit that there might be a problem with a model, right? Who here has had a PI in their office screaming bloody murder because the tech has done something and now the model doesn't work anymore? I don't believe you. There's a lot more out there. You're being shy, or I can't see you. Right? Well, the reason for this is that there are structural disincentives to ever considering potential issues with the model or admitting that the model may be flawed. And the most obvious one of them is the R01. So everybody knows what an R01 is, right? It's the big grant everybody's got to get. If I get an R01, I get promoted. Yay! I've got 5 years' worth of funding for my lab. Here's what you might not know. Depending on the institute, they're incredibly hard to get. The pay line for the institutes that I generally apply to is somewhere between 5 and 15% for first-time R01s. But a renewable R01, when you have finished and you've done everything that you said you would and you propose all of these new things that you're going to do, your chance of getting a renewable R01 is 5 to 10 times greater. So much so that they suck most of the oxygen out of the room in terms of funding. So, am I going to admit at the end of my 5-year project that I've realized that there's a problem with the model? Not if I want to keep my job, I'm not. Especially if I'm in a publish or perish institution, or even worse, in an up or out. For those who don't know what up or out is, it is barbaric. You have 7 years to make tenure, and if you don't, you are fired. Talk about structural disincentives. And so, who has had PI blackmail? I have had people in my office screaming, "You're jeopardizing my R01." Yes, everybody? Okay. My favorite, I had somebody in my office the other day who was like, this will be a paper in Nature. I'm like, wow, that's delusional. Like, as somebody who has actually published in Nature, I can tell you what the hit rate is, because we send every other paper to Nature just for, fun, right? Your chance of getting a paper in Nature, even if the experiment works out the way you expected, is minuscule. And you're so sure the experiment's going to work out exactly the way you expect right now? Well, that should worry you, right? That you already know what the result is before you've even got your animal protocol approved. Okay, so seriously though, when you interact with PIs like that, it sends off red flags for me. Let's get into the things that really send off red flags. Lack of clinical experience. So I admit fully that this is a mistake that I made. So for those of you who don't know, I work with trichotillomania, which is compulsive hair pulling in women, and other related disorders. And unfortunately, even though trichotillomania is probably the third most common disorder in women, it affects about 5% of women, it is massively understudied. So at the time that I started working on it, I had read every single thing that had ever been written on it, including by Freud, which, was sketchy. Bless him. But anyway. We are not all mid-1800s middle-class Austrian women, and a lot of that stuff doesn't apply anymore. Anyway, moving on. So I wound up at this NIH meeting, a strategic planning meeting for trichotillomania, in a room with these wonderful clinicians. I was like, oh, I just read everything you've written on trichotillomania, and I know everything there is to know about it. And in about half an hour, wow, was I taken to school. Because those clinicians, their diagnostic knowledge, the subtlety of what they know in terms of looking for things and how they're going to tweak their treatment in response to that stuff is never written down. And quite soon after that, I got involved in patient advocacy. And every single patient I have ever met has taught me something. And I have met well over 1,000 patients at this point in time. And as a result, I understand my model far better than I would if I had never engaged in that process. And I understand its limitations. I know exactly which kinds of patients it's modeling and which kinds of patients it isn't. And because I've seen the abject suffering in the eyes of those patients, I have something deep in my soul that prevents me from looking them in the eye and lying to them that I have a model if I don't. Does that make sense? And I think there is just something that brings out the fundamental humanity that I do believe is in every PI, more or less, if you force them to spend time with patients. And yet, the PIs that I meet in my role at Stanford, almost without exception, cannot tell me what the differential diagnostic criteria for the disease or disorder they're working with is. They can't tell me what the specific symptoms are. They can't tell me what the subtypes are. They certainly can't tell me what the key processes are to target in terms of quality of life. I go and ask your average autism researcher what the leading issue for quality of life is in autistic kids. And if they do not tell you repetitive behavior, they do not know what they are talking about. That is the major quality of life issue. It's the major reason why carers give up on autistic kids and go and find another job. But not many autism researchers know that. Anyway, so just to give you a couple of examples, if you are thinking about depression, seeing as Bernie brought up depression earlier, clinically, the key symptom that you need to worry about when you're treating somebody who's depressed is catastrophic thinking. Because if you can't treat that, no other treatment is going to take. And there is actually ways of measuring it objectively using something called judgment bias or cognitive bias. And people have reverse translated that into animals. How many of you have a depression researcher? Right? How many have ever heard of cognitive bias before? Oh, hey! What, from your researcher, though? Awesome! All right, maybe I'm going to have to stop using this example. Oh, okay, well, fair enough. Now, suffice it to say, dropping a mouse in a bucket of water and seeing whether it gives up or not is not cognitive bias. Anyway, my good friend and colleague Jeff Mogul is going to talk about the difference between chronic affect and acute reflex responses as in the issue of pain tomorrow, so I won't get into that. One of my other favorite examples is that if you know anything about palliative care, then all other things being equal, in breast cancer, again, beautiful data showing this in very large patient populations, all other things being equal, treatment, diagnosis, and everything, your major predictor of 1-year survival is whether or not you have a friend that you hang out with at least once a week. If you have no friends that you hang out with at least once a week, you are 5 times more likely to die. If you have no family members that you hang out with at least once a week, you are 4 times more likely to die. And if you have no children that you hang out with at least once a week, you are 2.5 times more likely to die. Do the math in your head. That's a 50 times increase in mortality risk. We know that. We manage that in palliative care. Oh, by the way, husbands don't count. That's the amazing thing about that data set. I wish they'd actually asked whether the women were gay, and if they were gay, if they were married, and then wives mattered. I mean, like, there's a whole other side story to that. Anyway, but guess what? The same's true in rats. So in Sprague-Dawley, which is a wonderful spontaneous model of breast cancer, the type of cancer, the invasiveness of cancer, the growth of the cancer, the responsiveness to treatment are all way less in group-housed animals than singly housed animals. However, cancer researchers freak out and are like, oh my God, variation, I can't control it, so they singly house everybody. Yay! Probably not a good model of humans then. Anyway. So another thing which as an IACUC you can look for is something that I call disorder shopping. So this is when somebody's made a knockout mouse and they say, oh, it's a model of X, it's a model of Y. And they shop it around until somebody bites and funds their next R01. So let's go with a couple of really famous examples. HOXB8. HOXB8 knockout mouse, incredibly famous knockout mouse, comes out of Mario Capecchi's lab. Yeah, he's the guy who invented knockout mice and won the Nobel Prize, so if anybody knows how to use them, perhaps it should be him. However, this mouse is a model of OCD, it's a model of trichotillomania, but unfortunately those two are differentials. Can't be both, it's got to be one or the other, and in fact it's neither, because it's actually self-injurious, so sorry. D1CT knock-in mouse, very, very famous mouse. That has been a model of OCD, it's been a model of Tourette's, it's been a model of trichotillomania, but never actually published as such, though they claim on their website, so on and so forth. It's actually not a model of any of them because that gene isn't expressed in the circuits in the brain that are involved in either of those two disorders. Oops. So, again, as an IACUC, you might not have the level of knowledge that I have about this, but you can at least spot disorder shopping. Okay, so a special version of this general problem of PIs not knowing the human clinical signs and symptoms is something that drives me absolutely insane, and this is in neuroscience specifically. It's depression-like behavior, autism-like behavior, anxiety-like behavior. All of these measures, these high-throughput phenotyping measures that people use, are dirty, what we call in true behavior dirty measures. That is that they're measures of multiple things and you don't know which. That makes you really prone to false discovery. So let me give you an example. The Morris-Water maze in mice is commonly used as a model of memory. In fact, it's the major output that's used in trying to find Alzheimer's drugs. Unfortunately, the single biggest predictor of a mouse's performance in the Morris-Water maze is how blind it is. That's what that graph is showing. Over 50% of the total variance in Morris-Water maze performance is due to retinal atrophy. So when you see a deficit or you see a drug that improves performance in the Morris-Water maze, you've probably discovered something that's affecting the visual system, not something that's affecting memory. Oh, and by the way, the memory deficits that we care about in Alzheimer's patients are hippocampal, right? I care that I don't have my short-term memory and my episodic memory is really impaired, and so I leave the cooker on and I set the house on fire, right? That's what we care about. The Morris-Water maze is a fear-based memory, right? So, you know, as was brilliantly put by my lunchtime companions, so what you're saying, Joe, is that we should be measuring whether or not the mice can remember where they left the keys, not whether or not they're going to die. Yes. That's my point. So anyway, and then we have behavioral neuroscientists. This drives me crazy. They'll often start, riffing on how animal behavior is just too fluffy and it's too hard to measure, and besides which we want high throughput and it's all just too difficult. Well, the last person who said that then went on with this bizarre talk about fMRI, which was purely correlative, right? So basically they were just doing phrenology with colors. And as an ethologist, somebody trained as an ethologist, I find those comments kind of offensive because ethology is the study of the meaning of behavior. It's the study of telos. This is why Bernie and I get on so well. It is possible to know what a behavior means to an animal. That's what ethologists study. So when I see somebody say anxiety-like, this means one of two things to me. Either they don't know how to test the validity of their measure, or they don't care. And neither is acceptable science. And this is why they won't let me on the IACUC at Stanford. Because seriously, because I feel that somebody who is using like measures simply shouldn't be allowed to do the experiment. Validate it. It's not hard. If you don't know how, go and ask an ethologist. Anyway, moving on. So to make this point, this is a paper that was studying escape-like behaviors in mice because these people wanted to know what people would do in a car park that was collapsing on them. So first of all, we drop a mouse in a tank of water. It's got these two little holes it can escape from. And then because we're worried about what people will do in a car park that's collapsing on them, let's put in... Now, for those of you who are paying attention, yes, there are animals drowning in this video. Okay, so this is the point where I hope I'm getting you as outraged as I am. The IACUC didn't stop this. The researchers didn't stop this. The peer reviewers didn't stop this. The journal editors didn't stop this. The journal did not stop this. And what is worst is that this video is the supplementary materials associated with the paper, because the researchers were so proud of what they had done, they didn't see anything wrong with what I am showing you right now. Our system is broken. The IACUC has to step up. Is everybody upset by what they're seeing right now? I'm sorry for showing you something upsetting. Okay, so just to finish this riff, the other thing that tends to go alongside this is the idea of a confirmatory experiment. So here's the thing, right? I'm a scientist. My job as a scientist, because I understand my experiment better than anybody else in the world, I am ethically bound to try and prove myself wrong, not try and prove myself right. A confirmatory experiment only tests for like technical errors, right? It doesn't test for alternative explanations, biological or developmental or psychological, right? And so this is an example of what we call in philosophy the bundle of sticks fallacy, right? 1,000 pieces of bad evidence does not make one piece of good evidence. And statistically, this is an example of the difference between a p-value and a q-value. So a p-value is only meaningful given hypothesis testing, for which I need a finite null hypothesis. And by the way, I'll knock out a gene and something will change is not a finite null hypothesis. That's the scientific equivalent of suck it and see. So when you don't know what's going to happen, you're actually looking at what's called a false discovery. It's the chance that any given observed result is actually false. And if you read people like John Ioannidis and you get into the math of this, then almost all unexpected significant results are in fact false discoveries, especially for highly sensitive, noisy measures like behavioral phenotyping. And so this is why we have got to the point, at least, thank God, with microarrays and RNA-seq, where we understand that we are basically going fishing. And when you are going fishing, you cannot use p-values, you have to use q-values. You have to use false discovery rate corrections. But the same is true whenever it doesn't matter if you're fishing for genes or fishing for behavior or fishing for whatever. So I don't care what kind of omics it is or what kind of typing it is, right? If there are multiple measures being taken and you don't have an a priori hypothesis about them, I'm sorry, then as an IACUC, you should just be looking at that experiment and going, you are using Benjamini Hochberg at least, right? And then the PI goes, what now? And then you have a nice discussion with a statistician. So this is for the vets. So I love this. These expert PIs who come into my office with absolutely no knowledge of basic comparative animal biology. So this is one of my favorite examples of this, not somebody at Stanford, but anyway, this is a German team. So they published this paper in Science, of all places, claiming that they had found a previously undiscovered new organ. Now, I'm not sure the last time that a new organ was discovered in mammals, but it was a while ago. Anyway, they claimed that they had discovered that mice have a second thymus on the side of their neck. And they went into incredible detail about which strains had it and which strains didn't and which strains were variable. And in fact, the title of this paper should have been Evidence that we don't actually know the shape of a mouse thymus and that we've been screwing up our ablations for our entire career. Because the mouse thymus, if you know anything about, comparative biology, is wishbone-shaped. And they were just assuming that the thymus in mice was like the thymus in humans and is diamond-shaped. So they were ablating here and leaving the thymus here. So, this was published in Science. The reviewers didn't know the first thing about what they were doing. The journal didn't know the first thing about what they were doing. And that's not bad enough. There's several of us that have complained about this paper. Guess what? It's still out there. It's not been retracted. Isn't that awesome? Anyway, so we also have PIs who have no idea about the technologies they're using. And a really good example of this is the flanking gene problem. So I'll regularly meet with people, and they're like, well, OK, I've got 6 generations of back crossing in, so my mouse is 95% congenic, and I'm ready to start my experiments, to which my answer is, no, you're not. Because, yes, it's true that at that point, all of your other chromosomes are basically black 6, but unfortunately, you have about 16 kilodaltons of DNA on either side that's linked. It's still 129. It's still heterozygous. And in the mouse, that contains 1,000 genes. So is my phenotype, I don't care if you've done PCR and the bloody thing is being expressed or not, right? I don't care. Is your phenotype statistically more likely to be due to the one gene you've manipulated or the 1,000 heterozygous genes that are on either side of it? You want to make that 1 in 1,000 bet? Apparently most people do. All right, stats and experimental design. So, by the way, I'm not saying anything that nobody else has said. I'm just saying it all really fast and with like rude jokes. So R.A. Fisher, kind of important person, invented biostatistics. So this is from his 1935 book, the first edition, if I remember, page 101, 103. Should have written down the page number. Anyway, the key points of this quote is that standardization, which is often thoughtlessly advocated as a panacea, put that to one side. Standardization, therefore, weakens rather than strengthens our ground for inferring a like result. He said that in 1935. Everybody else in the world bloody well listened. I'm sorry for swearing. We can't control variability, nor should we try, right? It's only in lab animals that we have this bizarre, delusional, Teutonic, the nail that will be hammered up, sticks up will be hammered down notion that we even can, or that it's a good idea, right? Medicine is about embracing variability. I need to know that different ethnic groups have different processing of a drug and the toxicity. I need to know all of this stuff. Like, I'm not going to go to the FDA and say, you know what, here's my drug trial. I'm going to do it in 42-year-old white males that live in one small town in Wisconsin with identical wives, identical houses, identical educations, identical jobs, identical diets. And I bought them all the same furniture, and they all have the same thermostat, which is also at the same temperature. And by the way, I've locked this thermostat so they can't change it. Oh, and they all have the same grandfather. Right? That's asinine. But that's your standard lab animal study, if you think about it. And so human brains and human experimental designs embrace and study this kind of individual variability. And as Hanno Verbel and Helene Richter and myself showed in Nature Methods, assuming variability is controlled and it is unimportant actually elevates your false discovery rate tenfold over what you would expect by chance. And simply adopting a human design, simply treating your animals as if they were people in the way in which you design your experiment, solves that problem. So to give you an example, this is an experiment from my own lab, just because this is what happens in experiments. It's not because I'm awesome at doing science, right? So this was an experiment we did, a behavioral measure. It's noisy and it's messy, but it has a bunch of internal controls. And there's two different ways that we can control it. We can take a human-style experimental design, which is actually what we did, and needed 17 animals to detect the effect that we had. We had about 25, as I remember, in this experiment. If we had done a naive t-test, we'd have needed 150. This was an effect size of 30%. If you get down to an effect size of 10%, we'd have needed several thousand. So as an IACUC, here's how to spot bad stats. We're going to use a t-test, we're going to use a regression, we're going to use a correlation, we're going to use an ANOVA. If they say that, if they're not talking about mixed models or GLIMs or things like that, they don't know what they're doing. Bring in the statistician. I have rarely seen a study that is not massively overpowered. So I told you 35 minutes, yeah. Oh, okay, right, okay, I'll cut it down. All right. Yeah. So, all of these PI failures that I've been talking about are examples of well-established principles in the philosophy of science, and just basic logic and reasoning. We give people this degree called a Doctor of Philosophy, right? Perhaps if we do, we should require them to take philosophy, right? I have many friends in many universities who are DVMs, and they have chosen, I would never have made it through vet school, for obvious reasons, right? And they've chosen to embrace and love whole animal biology and One Health medicine. And they often are not allowed to be PIs because they're not real scientists. Well, it seems unfair that if I have a student who's uninterested in clinical translation, doesn't want to meet patients, doesn't care about statistics, why should they have the privilege of being a PI? Let's give them technical degree names. So let's have a Doctor of Advanced Pipetting, a Doctor of Useless Mouse Manipulation, a Doctor of Hypothesis-Free Description, and they can go off and do what they like doing, but we're not going to give them a grant because they don't have the philosophy background to carry it out properly. And I'm actually deadly serious about this. All right, this is my last point. So the last thing that we do is we fail to take the animal's point of view. In other words, we fail to consider telos. We're all guilty of this. Engineers love to design solutions to engineering problems, right? So for instance, mice have been telling us that they hate IVCs for years. The first IVCs, mice voted with their poo and stuffed the poo into the air inlets, right? What do the engineers do? Move the air inlets out of the range of the mice rather than go, I wonder if the mice like being in an IVC. So for those of you, anybody here who's a vendor, seriously, can you please ask the mice whether they like the thing before you sell it to us? A good example of this is that most enrichments that are sold to us actually cause some form of problem. Really, the only one that doesn't are some of these paper-based nesting materials, and even not all of them. We use cold. You know, the real reason we house mice at 20 degrees C is to suppress aggression and to improve lactation, and that's the reason we do it. Nests provide warmth, they provide shelter, they resolve many of these issues, but they're seen as nuisance luxuries. I can't see my mice, not necessities. So I don't know if you know this, but this is what corncob is really used for. It's a sandblasting material. That's what it was originally invented for. Anyway, there's lots of videos you can go and watch of people sandblasting with corncob. The other problem with corncob is that it contains xenoestrogens, so much so that it increases prostate and breast cancer rates in rats. In some strains of rats, it completely suppresses reproduction. And that's this graph. And I love this one. These are folks who are looking at aggression in mice. The higher the number, the less aggressive the mouse is. And housing them on corncob completely blocked the effect of estrogen injections to suppress aggression, because these guys are getting so much estrogen out of the corncob. So the xenoestrogens probably come from a black mold that grows on corncob prior to processing. If your producer tells you that that is not true for them, then just look them up on Google Earth. I love spying on people with Google Earth, or at least producers. It's really fun. Let's zoom in on this little spot. There's a dump truck. There's a side loader. And as you can see, that pile of corncob has a lovely crust of black mold on the top that is mixed in as they pull the corncob out of the pile. And on that happy note, let's think about what we can do about this. So, as an IACUC and an AV, we're required to do CEUs, right, as vets, as doctors, as IACUC members. Why aren't the CEUs for PIs to prove that they spent time with patients or clinicians? And why don't we require that for grant review, paper submission, IACUCs? Why don't we empower the IACUCs to require changes in experimental design, right? They're allowed to require changes in analgesia. Well, having 10 times as many mice as you actually need is a bigger problem. Require that change. There's no difference. I don't see any difference. Wouldn't it be awesome if we actually had people submit videos of what the hell they're doing, right, to you? And you can see whether they have good aseptic technique. You can see exactly what this behavioral task really looks like. And then you can maybe go to your clinical colleague and say, do you really think this is a model of autism? When we implement a new material, a new nesting material, a new IVC, whatever it might be, why do the vendors not have to show us that there is evidence of positive benefits and a lack of harm? We require that for drugs before we give them to people. And at the policy and federal level, let's eliminate the dissent. If this is the easiest thing to do, can we just get rid of the renewable R01, please? Anybody from the NIH here? And let's set a standard where an unexpected result with nothing but confirmatory experiments is considered as unpublishable as a negative result, because it is. It's actually worse. Anyway, that's my happy thoughts for the day. Thank you very much for listening to me. Thank you so much for the honor of giving this lecture, and I probably burnt through too much time. I'm sorry.
Thank you. Thank you, Dr. Garner. Unfortunately, we don't have time for questions, but Dr. Garner, you will be around?
And easy to hit with a rotten tomato.
There you go.